insulation cavities were filled, and I didn't feel like there would be a big benefit to tear the entire house apart just to insulate the inside walls. So we left the fiberglass. Ceilings, a whopping R20 with a ton of thermal bridging. And the basement, which is still about the same, R2. We were blower door tested at about 5 ACH50, which for that house and for our area is not horrible. I was actually pretty surprised considering that the old double hung Woodwood Anderson windows didn't even seat in the sashes anymore, regardless of whether they were locked or not. So I don't know how we were achieving that metric unless Paul's blower door manometer was wrong. I guess I'll go back to windows. Like I just mentioned, old Andersons, 35 years old, double hungs, leaky, mostly single pane, some double pane. I think they just used whatever matched when they built the house. So there is room for improvement with this project. One thing I can say about this home is for the time that it was built, it was fairly well built. The walls are plumb, the roof has been assembled properly, everything's nailed off properly, and the basement is bone dry. So it was really a perfect candidate to put some money into, especially for a deep energy retrofit. So our strategy for changing this house and achieving passive house was basically the traditional ham, skip the intro to thermodynamics, forms of energy transfer. So heat, air, and moisture. Once we carve up these things, we're able to digest them, we can see what we're working with, and as long as we address these three components from a building science standpoint, we can actually design and build buildings that perform, I think, fairly well, or at least pretty good. Addressing the heat, we filled the house with cellulose. We did a chainsaw retrofit, pretty much. Well, I'll talk about that in a minute. We filled all of the rafters with dense packed cellulose as much as we could fit in. We cut the eaves off the house, glue in dense pack, wrapped the entire house in 5.5 inches of upcycled polyiso. We bought a truckload of polyiso from a company in Massachusetts, actually, Insulation Depot. So they trucked the polyiso to our house. It's ironic, and this whole conversation as I'm saying this makes me a total hypocrite because I am not a foam guy, and we put a lot of foam into this house. I tried everything I could to figure out a cost-effective way to wrap the house with TJIs, use cellulose, yada, yada, yada. I couldn't make the numbers work, even with having our crew do the work. So we went the foam route with this project. We also broke the basement away from the thermal envelope because I didn't want to deal with excavation. We broke the basement away with an open cell Icony product. I think it's LD200. It's a low density foam. Has a much lower global warming potential than the spray polyurethane foams, which I'm adamantly opposed to. And we used a lot of cellulose. I'm a big proponent of cellulose. Cellulose is cheap. The cost of installation of cellulose is anywhere from 3 to 5 to 1 versus what the cellulose itself costs as a product. We've taken all of our insulating and cellulose flowing in-house. We bought a commercial insulation machine and now just do all of our own insulating. It's much, much less expensive than paying an insulation contractor to come do it. Here's the 5.5, 5 5/8 actually inches of polyiso. We built a small addition on the front of the house. It's interesting to note because there were some drainage issues at the front door. So when we started this retrofit, we were just going to replace the front door with a passive house acceptable door. We tore the door out, We found some rot underneath the door. We tore into that. Then the rim joist was a little bit rotted, and the band joist was a little bit rotted. So we jacked the house up, and we replaced that. In order to jack the house up, we actually had to tear the steps off of the front of the house, and then underneath were like giant concrete steps. I knew the steps were there. I didn't know they were literally like poured concrete. So we brought an excavator in, got those out of there, and realized that I had a foundation underneath there. So I thought, oh, well, I've got a foundation. It's January. It's 50 degrees. And why don't we just form it up? We'll pour a larger slab and build an addition on the front of the house, and it'll only take a couple extra days. So that's what we did. So I tried to replace a door and ended up with an 86 square foot mudroom. And that's one of my favorite parts of the house now, because before the kitchen entry was where we would jam all our coats and boots and shoes, and the dogs would come in and out of there, and you literally couldn't get the door open in the wintertime as you were like jamming your way in with arms full of groceries. Here is the polyiso that was parked in my side yard in front of our woodshed for quite some time. It's a lot of foam. A truckload of foam is a lot of foam. So anyways, air barrier. We decided to do a straight up persist method, pressure equalized, rain screen, insulation strategy, right? Close. I think that's it. So this technique was pioneered by Errol Lohr and Robert Dumont at 31 Crescent Avenue in Saskatoon, Saskatchewan in 1982. The Cold Climate Housing Research Council, which Adam had mentioned earlier, has another take on this called the remote wall. Similar strategy. Basically, we cut the eaves off of the house. I thought this was a pretty cool, like Legend of Greystoke-ish main appropriate picture. And then we wrapped the entire house in ice and water shield. It was expensive. I couldn't figure out another way to ensure the airtightness that we were trying to achieve while applying all of the foam with 8-inch timber lock screws through the exterior sheathing. We actually had the grace of 3/4-inch exterior plywood. It wasn't 1/2 inch, so we didn't necessarily have to find studs. And I wanted to ensure sealability of all of those penetrations. We used, I don't know, probably 4,000 or 5,000 timber locks. Mark?
Did you think about a rubberized coating, a water-based rubberized coating that you can spray or roll on?
I did, and I looked into like an ExoAir product, or Tremco makes a product. I've used the Tremco product. I'm not too keen on it. I've seen it delaminate from various substances, including ABS. I haven't worked with it at all with polyiso. And this stuff was readily available at Viking Lumber. So I took my 7% discount and bought the ice and water.
There was a presentation at the Pass House Conference that was fascinating, and one of the bits was the LCA analysis of the different assemblies that other people see that one, and the ice and water shield was like, it was just news to me. It was, I don't remember, it was like some huge percentage of the LCA impact on a particular assembly that covered the building, and it just opened my eyes to that, because it's all goo and petroleum, I guess.
It is, yeah.
So
it is.
It just was one of the aha moments for me, because I've used a ton of that stuff.
At the time that we made the decision to do this, I don't know that I thought that the ExoAir was going to be unaffordable. I thought this was going to be less expensive. I know there's another product, is it BCI, the Prosecco. They have another air barrier, Fast Flash, or the R5. That stuff is super expensive. I've worked with that. I love that product. Yeah, it's good. But it's pricey. So we got out there in winter and we chose the ice and water shield, and I would be open to doing this a different way in the future. but it was readily available and it was pretty easy. So the entire house got wrapped. We blower door tested at that time. Oh no, at that time we blower door tested at about, we were about 0.8, 0.9 ACH 50. Since then we've gone back, we've fixed some leaks, we've addressed some stuff in the basement, we've foamed in some spots, we've got the smoke pencils out and spent some time running around. The 0.5, 0.65 ACH 50 I think is a little gratuitous. I think we're actually closer to about 0.7 in reality, and that's with a airtight wood stove and a drain closed, and no cheating. We did seal the air intake for the chimney for the boiler. So moisture, we removed all of the vegetation from around the perimeter of the house. We had to work there, and I didn't want to return that stuff. We transplanted all of those plants that you saw on the perimeter were transplanted around the periphery of our property, which sits on a plateau. So none of the plants were injured. I didn't know that we could transplant rhododendrons in Maine in January, but we did, and they live, are fine. Another example of extreme weather breaking the noise barrier, improved infiltration and exfiltration, and mechanical ventilation. This house is not a certified Enerfit Retro. We're in the process. It takes a little bit of time, and I'm doing all the certification myself on my free time, so it's a slow process. These are the final metrics pasted from the PHPP. This is with only part of the thermal bridging analysis. I don't have all of the connections, so I believe this is the foundation to sole plate connection and outside corners. We still have inside corners and some other stuff left to do. The windows is the same installation that we've been doing, which I should probably have talked about that a little bit more. So outside corners, minus 0.02, negative thermal bridge, which is pretty good. I'm impressed with how well the polyiso modeled and thermed. I was very surprised by this. We put 8 inches of open cell Isonine LD200 in the floor of the house, and then we wrapped the polyiso on the exterior down. That's a little bit less. We went down about 8 to 9 inches below the foundation, and then back insulated that with open cell foam as well. And there's a half-inch gap where the sheathing was between the polyiso and the foundation wall. And that's how we're modeling with that assembly and therm. To me, this is the star of the specific primary energy demand show. This is a Poma 2000, named after somebody's grandmother, apparently. It's a pellet-fired burner for a boiler system as a retrofit apparatus. This was going to be the last component of this particular house. We have not installed this yet. We've run out of money. We're going to wait till next year. But after this is installed, we'll be completely fossil fuel free and 100% on biomass. So you basically just bolt this baby up to your existing burner, throw some pellets in, and let her rip,